Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this session, I would like to explain about frame with Sidesway. So this frame, as shown in the screen, is Sidesway frame because the frame is unsymmetry due to geometry, because when we look at the column AB is an inclined column. So due to the geometry of the frame, this frame is unsymmetry. So we have to go back to the definition of no sidesway frame, where in no sidesway frame there are two conditions that has to be fulfilled. So number one is symmetry due to loading and due to geometry. And condition number two, to get the no sidesway frame, for no sidesway frame, if the frame is unsymmetry, either due to loading or geometry, or both loading and geometry, the frame will not sidesway if the frame is fully restrained. Fully restrained. Sidesway means the frame is tend to move to right or left direction, okay, depending on the loading and due to geometry as well. Okay, this frame, frame ABCD, this frame is subjected by uniformly distributed load of 5 kilonewton along member BC. The flexural rigidity for AB and for CD is the same. For BC, it is 2 EI. Column AB is inclined. So before we start to analyze this beam using moment distribution method, so please remember, using moment distribution method, we actually analyze member and moment. So the objective or the outcome of moment distribution method, we use moment distribution method to calculate internal moment, or we also call internal moment as member and moment, or it is also the bending moment. So what is actually this? What is internal moment? Internal moment or member and moment or bending moment refers to the moment occurs at each end. Moment occur at each end. For example, for this frame is like this. This frame is look like this, fixed at A and D. Okay, there are three members. A, B, BC and CD. A, B, BC and CD, three members, and it for each member it has two ends. So we will have 6 member and moment, or 6 internal moment. So for member AB, like this, the member and moment refers to this member and moment, and this is called as MAB, MBA, MAB, MBA. And for member BC, For member BC, there are two N, so it will have two N moment MBC and MCB. And for member CD, CD also has two N, So we will have MCD and MDC. So in total, we have six member and moment. Start from MBA for member AB, MCB for member BC, and MCD and MDC for member DC. Okay, so these are all the output that we are going to determine using moment distribution method. Okay, so if this is the free body diagram of each element, each member in the frame, so beside moment, there are there are the internal forces reaction as well as internal forces, and the system must be in equilibrium. Okay, at A it is actually fixed support. So at fixed support there are reaction. The vertical reaction, we name it as V1, V1, and this one in horizontal direction, this one is H1, H1, and uh, the system must be in equilibrium. So what happened is at point B for member AB, we will also have in opposite, in opposite. So the same force but in opposite direction. So this is MBA, the vertical direction V1. This is also H1, because the structure must be in equilibrium. For the whole structure and for each element. So actually, this is the free body diagram. This one is the free body diagram for member AB. For member AB. Okay, of course, V1 can also be written as AY, and H1 can be written as AX. And in this diagram, I just want to show to everyone that the V1 here is actually equivalent to this, because the system must be in equilibrium. So if we have 100 going up, there will be 100 going down. That is why if this is V1, this one also V1. So if this is H1, this is H1 as well. Okay, so we just need to understand about this, the internal forces in the frame. Okay, so let's do again, but this time for member CD. Because ND is fixed. So at fixed there are three unknown reaction. So we will have Y or V in vertical direction. This is V, H, And this, we must have the same but in opposite at C. The same but opposite at C means that we will have in this direction and in this direction. And of course, because of fixed support, there is moment here, moment, as well as, and the moment for the sign convention, for moment distribution method, sign convention, the moment that act on the member is clockwise. Clockwise. That is why at the beginning we assume all clockwise in clockwise direction. Okay, so at member CD, we label dy as V2, and V2 means we have V2 to be balanced, and we will have H2 here, and this H2 will be equal to this H2 unless whenever the column is subjected to any horizontal loading on the member. Okay, and then we have moment M, D, C. So what happened is at this position, we will have the same but opposite as well. Means that we will have this as H1, and we will have this as V1. The same but opposite. The same but opposite. And at C, we will have the same but opposite as well. The same but opposite as well. So we will have V2 is going down. V2 here is going up. This is V2. And we have H2 to the right. We will have H2 in left direction. So this is actually the free body diagram of each element that we are going to use this whenever we want to calculate restraining force. Okay, again. Okay, okay. This is the frame. Fix. Loading is given like this. Okay, the loading is given like this. Okay, so by looking at this frame, we know that there are two fixed support. Fixed has three, like this. 1, 2, 3, like this. So we put the free body diagram, means the reaction at support A and support D, to show the system is in equilibrium. The structure is in equilibrium. But don't forget, the system or the structure must be in equilibrium externally and internally. Externally and internally. So what happened is, if we draw the element or the member one by one, we do it separately. When we draw it separately, we will get 1, 2, 3. This is for member. This is for member. And beside member, we also have join. Okay, so let's focus on member first. So for the member, okay, at A, we will have 1, 2, 3. 1, opposite, the same but opposite, and moment. Moment, moment we remain clockwise. Clockwise at the beginning of the analysis. Okay, and move to CD. Move to CD. We will have a this is horizontal reaction, vertical reaction, and the horizontal reaction and vertical reaction must be balanced internally. So we have vertical and horizontal forces, internal forces in horizontal direction and in vertical direction. And don't forget, we have moment representing member and moment, or internal moment or bending moment. Okay, and now for member BC, we have member BC subjected to loading. Okay, so this, because in between this point B and this point C, we have this point B also. This point B. Don't forget, in between this, we have join. We have join. Join. This is join B. Join B. Join B. Okay. Join B. Just like we analyze beam. Okay. So this joint must be balanced as well. Element must be balanced, joint must be balanced. So what is actually occur is at joint B, here B, we will have opposite, 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 and opposite. The moment is opposite as well. Moment is opposite. But forget about this. Okay. But what I want to say is we focus on the free body diagram of element. But remember, when we distribute moment, the moment that we distribute is joint moment. So no need to understand too detail. Okay, just focus on the free body diagram of each element. Okay, so at B, we have to balance back whatever we have here. Okay, so we will have this one in opposite and this one. Same goes to C. We have to balance this and this. And don't forget, we have to apply moment. Moment, clockwise, clockwise. Okay. So for the vertical and horizontal forces inside this diagram, for AB, we label as V1, V1, and V1. For horizontal force, we label as H1. So this is H1, this is H1. Okay, for member CD, we label as 2. We label as 2. So this is V2, this is V2, this is V2. And for horizontal force, it is H2, this is H2, this is H2. For the moment, we label as 6 member and moment. Member and moment. So we just need to label as MAB, MBA, MBC, MCB, MCD, and MDC. Okay, so this is actually representing the free body diagram for each element, having the internal forces. Remember, internal forces, there are 3 types. We have uh, the shear force, the normal force in horizontal direction, vertical shear force in vertical direction. That is why we label as V, and the moment, the bending moment. So at each end, so we will have three types of internal forces: shear force, horizontal force, as well as moment. Okay. Okay, so when we back to this frame is Sidesway frame due to the geometry of the frame. And in order to analyze this, we will have uh, to use the principle of superposition. So under the principle of superposition, we will have two frame condition. Number one is called as no, I will label as A, no side sway frame. This is the condition of frame under the principle of superposition. B, side sway frame. No side sway frame and side sway frames. So we will analyze the no side sway frame and the side sway frame under under step number 2 and step number 3. Okay, so we will continue in the next video with the first step of analysis of this frame using moment distribution method. The first step is to understand about stiffness factor and the distribution factor of the frame, of this frame. So we will calculate together what is the stiffness factor, what is the joint factor, as well as distribution factor. Okay, so thank you very much. We will meet again in the next video. Thank you.